Okay, so we talked about future value calculations in our last presentation. We're now going to talk about present value calculation. Let's say at the end of 4 years, you want to have in your account $1 and you can earn interest rate of 8% on an annual basis. The question is, how much do you have to invest today in order to have in the account $1 at the end of 4 years? So we can work backwards to see how much money we have to invest today. That's called the present value in order to have a future value in the future. Perhaps you're saying, well, why do we do that? That's a great question. It's called savings, people, and you're trying to invest for the future. Let's say that your child is going to college, or actually, you guys are in college yourself. You guys are still young. Let's say you want to buy a car in 5 years or in 3 years, so 4 years. That car is going to cost you a certain amount of money. So you want to invest money today in order to save up for that car. So we're saying, how much money do I have to invest today, present value, in order to accumulate a certain sum at the end of a certain time period? So to do a comparison, we're going to take a look at our present value calculation. Remember before we said that if I were to invest $8 into an account today, I will have in the account at the end of 4 years $108.84 based upon an annual interest rate of 8% and a 4 year investment period, right? So the 108.84, that's going to be the future value amount. So now we can actually kind of work a little bit backwards using our present value table. And we can say, how much do I have to invest today in order to have in the account 108.84 based upon an annual interest rate of 8% and investing for 4 years? I can now use table 12.3, which is called the present value table, to get my present value factor to determine the amount of the present value. So using the present value table, you will look up 4 periods, 8%. The factor C is 0.7350. Okay? You multiply that factor times the future value, it gives a present value of $80,000. Now, from an accounting standpoint, we're saying that if I invest $80 a day, based upon these terms, I will have in the account 108.84. Therefore, $80 is the present value of 108.84 based upon an 8% annual interest rate and an investment period of 4 years. You follow that? I hope so. So let's do some other calculations. Renee needs $20,000 for college in 4 years. She can earn 8% compounded quarterly at her bank. How much must she deposit at the beginning of the year to have $20,000 in 4 years? So $20,000 is the future value amount. We want to know, what is the present value of $20,000 based upon an 8% interest rate compounded quarterly over a 4 year period. You must first determine the number of interest payment periods. Because it's compounded quarterly, that means 4 times a year times 4 years, there will be 16 interest payment periods. Take your annual rate 8%, divide that by 4, because it's compounded quarterly, that gives us a rate of 2% per period. So our factors are going to be 16 is our n, our rate is going to be 2. Going to go to our present value table, go to my table, Look up 16 as my N, and my rate being 2%, so that's right here. That gives me a factor of 0.7284. Again, my factor is 0.7284. I'll multiply the factor times 20,000. That gives me a present amount of $14,568. So, if you were to invest today, 14,568, that's here, leave it in the account for 4 years, earn an interest of 8% annually, but we're going to compound interest quarterly. At the end of 4 years, you will have in the account $20,000. So we can use our present value tables to determine the present value of a future amount. Okay? Let's do some problems. We have Lynn on a local subway shop. They loan $40,000 to Pete. Pete plans to repay them at the end of 8 years with 6% interest compounded semi-annually. How much will Lynn receive at the end of 8 years? Okay, so it's an 8-year period, 6% annual interest rate, but compounded semi-annually. So our N would be 16 periods, twice a year for 8 years, 16 periods. And our interest rate is going to be 3% per period. You take the annual rate divided by 2 because it's semi-annually, the rate is going to be 3% per year. And we're saying how much will Lynn receive at the end of 8 years? We're looking for a future value. We're going to look up N is 16, I equals 3. So the factor is 1.6047. So if we look up N equals 16, I equals 3, there it is. I told you 1.6047 is your factor. So now we'll take that factor times the 40,000. At the end of 8 years, Lynn is going to receive $64,188. That's not a bad investment. Next problem. Melvin has difficulty deciding whether to put his savings in Mystic Bank or Four Rivers Bank. Mystic offers 10% interest compounded semi-annually. Four Rivers offers 8% interest compounded quarterly. Melvin has $10,000 to invest. He expects to withdraw the money at the end of 4 years. Which bank gives Melvin the better deal? What do you think? Let's begin with the Mystic Bank. It's a 10% interest rate compounded semi-annually. Okay? So you take 10%. Well, we do the years first, or the number of periods. We're going to take, he's going to invest for 4 years, twice a year, 8 periods. 10% divided by 2, the rate is going to be 5% per period. So using your future value table, you'll look up N equals 8, I equals 5 in order to get your future value factor, which is going to be 1.4775. We'll take that time 10%. Mel will get a total of $14,775. Now, if we go with the Four Rivers Bank, they're doing interest compounded quarterly. So we got 4 years times 4 times a year, 16 periods. The rate is 8% compounded quarterly, so the rate is going to be 2% per period. So now N equals 16, I equals 2. Using your future value table, it gives you a factor of 1.3728. So with Four Rivers, you will earn $13,568. $728. So we see that Mystic Bank is the better offer. He'll earn more interest with Mystic Bank because of the higher interest rate than he would earn with Four Rivers. So using our chart, so we got 8 and 5. So look at our chart. If I look at 8 periods, 5%, you see the 1.4775, okay? And if I look at 16 periods at 2%, let's go back. 16 periods at 2%, you see the 1.3728 is right here. And that's where we got those factors. So we can use the future value table to determine the future value amount of a current investment. Okay. For our last problem, Lee deposits $15,000 in a new savings account at 9% interest compounded semi-annually. At the beginning of the year 4, he deposited an additional $40,000 at 9% interest compounded semi-annually. At the end of 6 years, what is the balance in Lee's account? Okay, so this one is a little bit more thought-provoking. So first, we did $15,000 in a new savings account, 9% interest compounded semi-annually. So we did it for 3 years. Why is that? Because the amount invested would change for year 4. So we're going to do the first 3 years. So where interest is compounded semi-annually, twice a year for 3 years, there's 6 interest payment periods. The rate is going to be 4.5% per period. So you will use your table, future value table, you will look up 4.5% as 6% to get your factor of 1.302. Take that times 15,000. So at the end of 3 years in the account, he will have $19,534.50. At the beginning of year 4, he invested an additional $40,000. So now in the account, total is $59,534.50. We're going to have years 4, 5, and 6, 3 more years. So the same factors you're going to have is 6 periods at 4.5%. You get the same factor of 1.302. But now we'll take that times the $59,534.50. So at the end of 6 years, Lee will have in the account $77,531.78. Not a bad investment. This will conclude our discussion in Chapter 12 on how to calculate compound interest. If you need further clarity, rewind these video lectures, or feel free to contact me, your instructor. Bye-bye.